So yeah, today we're going to solve this question number 120, that is triangle. And what does the question says? The question says that you're given a triangle array. So we are given an array as an input. So we need to find the minimum path from top to bottom. So like this is the triangle we can assume of that we are given. And so like we need to find the minimum path. So the path can be like this, and this, or it can be like anything like this. So path can be from top to bottom. For each step you may move to an adjacent number of the row below. So if we are moving from top to bottom, we'll check like we can move the bottom, like the row we need to move down towards the row that is bottom, and we can move the very column we are standing on, or the one adjacent to it, I plus 1, either index I or index I plus 1 on the next row. So if we are starting at index 0, so we can move to index 0 or 1. If we are at index 3, so index 2, so we can move to index 2 or index 3 given we start from 0. So like how can we do this? How can we find the minimum paths from top to bottom? So like yeah, these are connected, and suppose like the example that is being given, 2, 3, 4, 6, 5, 7, 4, 1, 8, 3. All right, so if we take this bottom row as a DP array, if we take the bottom row as a DP array, we can find very well like what is the minimum path. Let me show you how. So as of now, DP array is 4183. Yeah, 4183. So we start from here. We start from, that is row 2. This is row 3, row 2, row 1, 0, 0. And we check what is the minimum between the index 0 and index 1, because we are in index 0. So this is minimum. We can pick this. So 6, we can take like the DP array is going to DP of J, it's going to be minimum of the current value, that is 6, plus minimum of 4 comma 1. So we take 1. This is going to be 7. Yeah, 7. And we move here, and among 1 and 8, what's going to be the minimum? 1, right? So this is going to be 6, 7, 6. And for here, in between 8 and 3, what's going to be minimum? 3. So this becomes 10. So this is 10. Alright, so the current values are 7, 6, and 10. Alright, so this is the array as of now. Now we are at row 2, this one, and we take one of 7 and 6. What is the minimum? 6. Yeah, 3 plus 6 is going to be 3 plus 6 is going to be 9. And for 4, we are at index 1. So index 1 and 2, what is the minimum? 6. So this becomes 10, and this becomes 9, and this is 10. And the final is going to be, we take we are at index 0, so we take index, we'll consider one row bottom, 9 or 10. What we are going to take? 9, because obviously 9 is smaller. So this becomes 11, this becomes 11, and 11 is going to be a final answer. So this is how we can solve this. It was a pretty easy question. We take the DP array as 4183, the bottommost row. We are not initializing at 0 like I saw some other solutions. They were like the initialized array of 0, and the number of elements that are present, the length of the triangle array we can take plus 1 multiplied by 0 is the length of the DP array, but we are not going to do that way because it's much more easier. So yeah, let's just code this up. Okay, so DP equals to triangle minus 1, the bottommost array for I in len of triangle minus 2 minus 1 minus 1, so that we iterate up to from second last row to 0th row, and this will go from for j in range, and this will run up to len of current subarray. Alright, and dp of j is going to be triangle of I j, that's the current value, plus minimum of dp I, or like dp I, the current index we are standing on is, yeah, so it's going to be j, and dp of j plus 1, and we return dp of 0 here, and let's just submit this, check. So yeah, it's accepted. Memory 92.79, yeah, runtime 80.31. So as I said, like, it's much more efficient, it's much more better. So this was the triangle problem. See you in the next one.